You've seen them in movies and on TV, right? Those big, futuristic-looking medical scanners. But have you ever really stopped to wonder how they actually see inside our bodies? Well, today we're pulling back the curtain on the incredible and honestly pretty surprising science behind this amazing technology. So let's just kick things off with a quick question for you. When you think about an MRI scan, magnetic resonance imaging, what's the first thing that comes to mind? Do you picture a doctor injecting some kind of magnetic liquid into your veins to get that image? It's a super common idea, but is it actually true?
The answer is a big, resounding no. Nope, that is a total myth. The reality is actually way cooler, and it has everything to do with what's already inside of you.
So if there's no magnetic fluid, what in the world is going on in that machine?
Well, the secret is you. Specifically, the countless hydrogen atoms that are packed into your body's water molecules. The whole MRI machine is basically designed to have a conversation with those specific atoms.
Okay, so here's how it all goes down. First, that giant, powerful magnet acts like a drill sergeant, forcing all your little hydrogen nuclei to snap to attention and line up in the same direction. Then, zap! A pulse of radio waves comes in and knocks them all sideways. When that pulse shuts off, the nuclei relax and pop back into alignment. As they do, they release a tiny little energy signal. The scanner picks up on millions of these signals, and a super smart computer translates all that data into the incredibly detailed images we see, all without a single magnetic injection.
Now, I know what you might be thinking. Hey, wait a minute, my uncle got an injection for his MRI. And you're probably right. That definitely happens. But here's the thing, what's being injected isn't magnetic at all. It's an optional fluid called a contrast agent, and its job is just to make certain things like tumors or blood vessels stand out and show up way more clearly in the final picture. So, let's just clear the air on a few other common myths real quick. First, we've busted the magnetic fluid idea. It's all about your body's own atoms. Second, and this is a big one, MRIs do not use ionizing radiation. That's for X-rays and CT scans. MRIs just use magnets and radio waves. And finally, that crazy strong magnet, it doesn't actually pull on all metal. It only poses a real danger to specific types of metal that are strongly magnetic, like iron, which is why they're so careful about screening you for things like keys or jewelry beforehand. Okay, so we've established that MRIs are fantastic, right? But it's really just one tool in a much bigger medical toolbox. To get the whole picture, we need to take a look at some of the other scanners doctors have at their disposal. All right, let's compare the two heavy hitters, MRI versus CT scans. We already know MRI uses magnets, it's radiation-free, and it's the absolute champion for looking at soft tissues. Think your brain, muscles, or ligaments. A CT scan, on the other hand, is basically a super-powered 3D X-ray machine. It does use ionizing radiation, but it's way, way faster than an MRI, which makes it perfect for emergencies, like checking for internal bleeding after an accident.
Now for two other very common ones, you've got the classic X-ray. It's super fast, it's cheap, and it's fantastic for looking at dense stuff like bones. Then you have ultrasound, which is kind of the opposite. It uses sound waves instead of radiation, so it's incredibly safe. That's exactly why it's the go-to for checking on a developing baby during pregnancy. Plus, it gives you a real-time moving image, which is amazing for watching something like a beating heart.
This little chart kind of lays it all out, doesn't it? You can see which scanners use radiation, which don't, and what they're each best for. But hang on a second. Take a look at that last one, a PET scan. It says it uses radiation from a tracer, and it's best for metabolism? What does that even mean? This is a totally different way of looking at the body.
And this, my friends, is where things go from really interesting to straight up mind-blowing. See, all the other scanners we've talked about, they show us the body's structure, what it looks like. A PET scan is completely different. It shows us the body's function, what it's actually doing on a chemical metabolic level.
In fact, the physics behind how a PET scan works is so wild, it sounds like something they pulled directly out of a Star Trek script. It uses a concept that most of us only ever hear about in sci-fi movies.
What are we talking about? Antimatter. Yeah, for real. Specifically, a particle called a positron, which is the literal antimatter twin of an electron. And yes, during a PET scan, this stuff is created inside your body.
So here's how it goes down. You're injected with this special radioactive tracer that's attached to a sugar molecule. Now, really active cells, like cancer cells, are super hungry and gobble up a ton of sugar, so this tracer starts to build up in those spots. Then the tracer does its thing. It emits a positron, which travels a teeny tiny distance before it inevitably bumps into its mortal enemy, an electron.
And what happens when a particle of matter meets its exact antimatter counterpart?
You get annihilation. Poof! The two particles vanish, converting their entire mass into pure energy. And this isn't some abstract theory. It is a real physical event happening millions of times a second inside your body during the scan. It's just incredible. That tiny explosion of energy from the annihilation shoots out two high-energy particles called gamma photons in perfectly opposite directions. The big, ring-shaped PET scanner is designed to do one thing: detect these pairs of photons that arrive at the exact same instant. By tracing millions of these photon pairs back to their origin point, the computer can build a detailed map showing exactly where the most metabolically active hotspots are in your body.
Now I know what you're thinking. Hold on, antimatter, annihilation, inside my body? That sounds absolutely terrifying. But I promise you, this absolutely incredible process is perfectly, completely safe. And here's why.
The amount of antimatter we're actually talking about here is almost unthinkably small. We're talking about a trillionth of a gram. A single grain of salt weighs millions and millions of times more than all the antimatter created during your entire scan. So while the idea of antimatter is powerful, the amount here is truly infinitesimal.
So let's just break down the safety facts. The amount of antimatter is microscopic. It only exists for a tiny fraction of a second before it's gone. The radioactive tracer itself has a really short half-life, about 2 hours, meaning its radioactivity fades very quickly. And your body just naturally and safely gets rid of it all within a day or so. The overall radiation dose is low and very carefully controlled.
So when you step back and look at it all, from using the simple hydrogen atoms in our own water, to using sound waves, to literally harnessing matter-antimatter annihilation, it's just an absolutely incredible toolkit. These technologies are a huge reason modern medicine is so effective, letting doctors see what's happening inside us in ways that would have seemed like pure magic just a few generations ago.
And that really leaves you with a final thought, doesn't it? We have figured out how to safely use some of the most fundamental forces in the universe, powerful magnets, radiation, and even antimatter, all just to peek inside the human body. It just makes you wonder, what on earth are we going to come up with next?